Okay, so guys, remember when it's in condensed form, our job is to expand it. So we're gonna expand this, and this is addition of sine. So we want sine alpha, sine pi over 2. And when you have sine, you keep the sign the same. So minus, and then we're gonna do,
Wouldn't it be cosine pi over 2?
yes, I'm sorry. Sine alpha cosine pi over 2. And then we're gonna do cosine alpha sine pi over 2. Now then you find the values of what you want, of what you need, okay? So which ones are we gonna find the values of? It would be here and here. I can't find sine of alpha. I don't know what alpha is. I don't know the angle. But you can use your unit circle and find cosine of pi over 2. So here's your unit circle. Here's pi over 2. Cosine is 0. So then I'm gonna have sine of alpha times 0. What happens when you multiply anything by 0? It just goes away, right? So that's gone. Okay, now on this side I have sine of pi over 2. So I'm gonna go to pi over 2, and sine is 1. So this value here is 1. So now I've got negative cosine alpha times 1. Well, anything times 1 is just itself. So the answer then is just negative cosine alpha. Okay? Now then, let's look at the second one. The second one is a proof. And guys, it's almost exactly the same of what you just did. It's very similar. We want to prove, we want these two sides to equal each other. Right? You can only expand the left side. This is the only side you can do anything with. So you're going to go ahead and just simplify the left side and make it match the right side. There's a proof on your test tomorrow. Right? So you're going to expand this side. This is cosine. Okay, so we're going to say cosine of x. And then you're going to do cosine of pi over 2. Change the sign. Sine of x and sine of pi over 2. And it looks almost the same as the problem we just did. Okay, instead of alpha though, they're using x. It doesn't matter what you call the angle. Okay, now then you find this value and this value. So cosine at pi over 2, use your circle again, cosine is 0. So this is cosine of x times 0. Well guys, it goes away. Guys, sine at pi over 2 is 1. So you're going to have negative sine of x times 1 equals negative sine of x. Well, negative sine of x times 1 is just negative sine of x equals negative sine of x. And you've now proven that each side matches. So on your test, you have to have this part and then this part. Okay, you have to have both. It's a proof. Okay? All right, so now then, let's move on. Okay, so take out your review sheets, guys, please. And I'm going to go over first numbers 4. Okay, they're on your review sheet. I'm going to do number 4. I'm going to do number 9. And I want you to set up. I want you to set this problem up here, the one on the back, and set this problem up here. Okay? So I want you to do 4 and 9, and I want you to set these two up first. And then I'm going to go over them. Those are the important ones I want you to know how to do before tomorrow. I'll give you a few minutes, and then I'm going to work them for you. Okay, so let's flip it over then. I'm going to actually work the problems that we talked about with you. We're going to start at number 4, okay? And some of you are still confused about how to do these type of problems where it says 11 pi. Remember, on your unit circle, okay, you would need to go through and change your spots to 12ths. So the first one, for example, this is pi over 6. We're going to write it as 6 times 2 is 12, so pi times 2, so 2 pi out of 6. which is also 30 degrees. Then you go to the next one, and it's pi over 4, and you want to change this one to 12ths, which will give you 3 pi over 12, which is also 45 degrees. And you keep going around your whole unit circle and write all your radians in 12ths. Okay, and if you do that, right, you will end up with, over here at 120 degrees, turns into 8 pi over 12. So what I did is I did sine of 8 pi over 12 plus 3 pi over 12. That gives me 11 pi out of 12. But I don't like to leave them in this. I like to turn them back into the degrees. You can leave it like that, or you can turn it back, whichever way you feel more comfortable. But remember, 8 pi out of 12 is the same thing as 120 degrees. And 3 pi out of 12 is the same thing as 45 degrees. So I could just write sine of 120 plus 45. You can do it either way. Okay, then when you get this far, you have to expand it. So that's like saying sine of 120 is cosine of 45 plus cosine of 120 and sine of 45. And you find the value at each spot. So this is root 3 over 2, there's root 2 over 2, plus negative 1/2, and then root 2 over 2. Once you get this far, remember you have to multiply this part together. So this is like root 6 over 4. You have to multiply this together. There's a negative 1 on top, so this is negative root 2 over 4. So in your final answer, it didn't matter. If you have them flipped, that's fine. As long as the root 2 is negative and the root 6 is positive, you're fine. So then in your final answer, to clean it up, it would be here. Root 6 minus root 2 all over 4. So that's number 4. Okay, I also asked you guys to work number 9. So let's take a look at number 9. Now, once again, if you don't like dealing with these radians, you have two options, because this is tangent, right? So what this really means is I want tangent of pi over 3, it's minus 5 pi over 6. So you'd either have to get a common denominator, okay, and find it, or you can just change them to degrees. Look at your unit circle. Pi over 3, okay, is 60 degrees. So I'm going to change this to 60, and then go in your unit circle and find 5 pi over 6, and it's the same thing as 150. So what I really have is tangent of 60 minus 150. Okay, 60 minus 150 would give me tangent of negative 90 degrees. Now, if you think about that, if you take a look at your unit circle and kind of use a little reasoning here, okay, it's been a while since we've done this, but a positive 90 would lead you from here all the way up to pi over 2. A negative 90, instead of going this direction, you go the other direction to here. So here's negative 90 way down at the bottom down here. And it's asking for tangent, and tangent down way down here is going to consider undefined. So that's the reason it's undefined. So this is an undefined answer.
On the exam, like for a problem like that, do you want the exact one?
I'll take either.
So tangent of a 90 or
Yeah.
whatever.
It doesn't matter. I'll take either answer. Okay, now then, go to the back. And I'd asked you guys to set up triangles for problem 13 and set the triangles for problem 17. You guys know setting up the triangles is the most important part, okay? You gotta set them up correctly or you're gonna do the problem right. Now if you read the directions, here's cosine of alpha is 3/5, cosine of beta is 35 over 37. That's not a big deal. Where you guys run into trouble is that I'm telling you alpha and beta are acute. What does that mean? Where on the grid would alpha and beta be if they are acute? what quadrant are acute angles in? What does an acute angle mean? Right, quadrant 1. Acute means less than 90, right? Well, if this is less than 90 degrees, they're both in quadrant 1. So both alpha and beta in quadrant 1. And I'll let you fill in the rest from there.
I just think it is.
Now, we have to be careful. Someone said that they're saying, oh, well, these are both positive, so they must be in quadrant 1. That's not true. Cosine is the x-axis. Cosine is positive in this quadrant and in this quadrant. So they could have been in either one. You had to actually look at the clue it gave you. All right, now, let's look at 17. Let's set this up. Okay, on the quiz, there's a problem like this. If I'm telling you cosecant is 13 over 5, okay, then the flip of cosecant is sine. So then I'm telling you that sine of alpha, and we have to flip this, is now 5 over 13. Remember, we gotta trade it. And then it gives me information about tangent. That's okay. Now let's set alpha up. Here's alpha. And alpha is in quadrant 2. And here's beta. And beta is in quadrant 3. I'm going to actually help you set these triangles up in case you struggle with this still. Okay, it talks about alpha. Alpha says sine. That's opposite over hypotenuse. So that's 5 over 13. I have a hypotenuse and a leg. Remember, hypotenuse is always going to be labeled positive. And then you also know you've made a mistake if any part of your triangle gives you a decimal. So for example, by accident, if I try to take 13 squared plus 5 squared and I get a decimal, I know I did something wrong. Okay? I'm going to take 13 squared minus 5 squared in this case. Right, and it's going to give me 12. But it's in this quadrant, so it's negative 12. If you forget that negative, you might as well stop doing the problem, right? Because you're not going to get it correct if you don't have the sign right. Looking at beta, this is x is negative and y is negative. Okay? And it tells me tangent is 3/4. So opposite over adjacent is tangent. So the opposite is 3 and the adjacent is 4. Now look, there's no negatives written here. But they are actually both negative. That's because a negative 3 divided by a negative 4 is a positive 3/4. Tangent is allowed to be down here because it's positive. So you have to watch your signs. And if you have a 3 and a 4, the hypotenuse is always positive, and that's a 3, 4, 5 triangle. When you type this in your calculator, if you're not sure, remember you have to have parentheses around the negatives, or just drop the negatives. Either way. Now, I'm going to actually help you set one of these up because kids are still struggling with the tangents. I'm going to help you set up number 17 so you can make sure you understand how to do it in your calculator. So you want tangent of alpha. Okay? So tangent of alpha is right here. That's opposite over adjacent. So that's 5 over negative 12. It's a minus, so we're going to put minus. Then you need tangent of beta, which is right here, and it gave it to me. It's negative 3 over negative 4. So you can leave it negative 3 over negative 4, or you can just change it to 3/4. Either way is fine. Okay? I'm just going to write it negative 3 over negative 4 because that's how y'all see it. Over 1 plus, and I'm going to put these back down here. Now for practice, to make sure you're doing it right, type this in your calculator at the top. Okay? You're actually going to type it in the calculator as negative 5/12. Because some of you, this is where you're making your mistakes. Divided by negative 3 divided by negative 4. And then you go to math, enter. And you get negative 7/6. Try to make sure it's correct. I just entered in the top. That's all. And I wrote down my answer as a fraction. Then we're going to type in the bottom. So we're going to say 1 plus inner inner, and I got 11/16. Now on your calculator, you're gonna actually type -7/6 divided by 11/16. So I'm gonna take -7/6 and divide by my 11/16 that I got, and hit math inner inner, and it'll give you the right answer, -56/33. Okay, continue working. If you get stuck, you can ask questions. The answers are on the bottom to make sure you're accurate.